So continuing on with where we left off, we're going to talk about constructing a stem and leaf plot now. Another way we can deal with continuous data. So we've got, it's just a graphical organizer that takes quantitative data and uses the digits to the left and the rightmost digits to form a stem. And so each rightmost digit forms a leaf. So for example, what that means is 147 would be written 14, and then you'd have a dash, and then you'd have a 7 on the other side. And so you don't lose any of the data by doing this. TI calculators do not have this function, so you can't really do it with that, but I'll go through the process of doing this with you. If you want, you can pause the video to read this. But we're going to use this data, and we're going to construct this thing. So the lowest value is 8.6, I think. So we need 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, and I think, oh, there's 20, 21, and 22. Okay, so 20, 21, and 22. I hope there's not anything bigger, but what we would do, and I'm not going to do all of this, but you'd write all this, and then 8.6 is our first one, I believe, so I think I'm going to put a 6 here. So this represents 8.6. So I've used this one. Are there any other 8s? No other 8s. Okay, so we got a 9. 9 is 9.6. Is there any other 9s? I don't see any. None. So we got a 10. We have 10.5. There's 1. We have a 10.8. 2 5s. A 1. There we go. We got a 1. So do we have a 10.0? No 10.0. So we've got a 10.1 and 2 5s and an 8. So this would read as 10.1, 10.5, 10.5, and then 10.8. So that would be this one, this one, this one, and oh, we got a 10.2. I missed one. So we want to make sure we put them in the right increasing order. So 2, 5, 5. So New Jersey, where is it? Here it is, gone, and 10.5. Oh, we did have a 0, so we can add a 0 there too. So, as you can see, this one kind of, you have to make sure you don't miss any, but they would come up later. Sooner or later, they would come up anyway. So, if we did 11, we have 11.2, 11.2, 2 of them, 11.6, 11.0, so that would be first, obviously. So that's this one. 6, 5. And so we have a 0, a 2, a 2, a 5, right? 11.5. We have 11.6, 11.6, 2 6s. There's an 11.5, 6 and 6. So 11.5, 6, and 6. Now I don't see, oh, we had a 10.7. So we got to put that up here too. Okay, so that one's gone. We have an 11.8. So you can see this is kind of very tedious. We just kind of keep going back and plugging them back in, but it's not too bad. So let's just make sure we get all the 10s, 11s. I'm not going to do the whole thing, obviously. We have a 10.5 I didn't even count, right? Wow, there's a 5 I missed that's right in the beginning for 10.5. So there's 3 5s. Here's the other one. Okay, so as you can see, like, I'm obviously missing some. I usually do this with the class. It's a lot of data to keep track of. And as we do it as a class, you know, with so many eyes on it, it's very hard to miss anything and have to go back and add it. But as you can see, I'm kind of having to do that frequently here. So with that being said, we're done with this example for now. Obviously, the next slide is just constructing with the class. If we do a dot plot, this is pretty straightforward. What you would do is let me do it real quick for you. Come on, let me copy this. Copy. A dot plot is pretty straightforward. It would be something, what? It didn't copy it. What? Let's try it again. Copy. Delete. What are you doing? All right. Here we go. Dot plot would go something like this. So it's 1, 2, 4, 5, 6, 7, 8, 9, 10, and 11. 7 is first we put a dot. 6, we have a 6, another 6, a 4, another 6, a 2, another 6. And you literally just keep going as we're doing it like this. 6 and 6, 11, 4, 5, 7. So as you can see, you can kind of see the pattern starting to show up a little bit better here. 2, 7, 1, 2, 4, 8, 2, 6, 6, 5, 5, 3, 7, 5, 4, 6, 5, 4, 6, and 2, 2, 9, 7, 5, 9, 8, 5. Okay, so there's your dot plot. So that's pretty straightforward, pretty quick. Just putting dots with numbers, basically. This is obviously discrete. And then the last thing that you will need to know, obviously, is shapes of distributions. It's probably one of the more important parts of this section. So important notes, we do not describe qualitative data as skewed left or skewed right or uniform. Data will not always exhibit behavior perfectly matching any of these shapes and can be left up to the observer to decide whether or not they are that shape. And so let's look at them real quick. This is uniform. That's one of the top left one is uniform. That is one where they're all about the same. If they're relatively the same, meaning maybe some of these are 18 and some of them are 21 and all the numbers around 20, I guess we could technically say that is uniform too. It doesn't have to be completely flat, just as long as they're close to each other. If we look at the letter B, which is the top right, that's a bell shape, and that's what we call the normal curve, which you will have to be very familiar with. The bottom left is skewed right, and with skewed right, what you would see, the way you keep track of what they look like is your skewed right looks like your right foot. It's got your big toe is sticking out the furthest, and so it gets smaller as you go down to the right side. And so skewed right looks like your right foot, and skewed left looks like your left foot. And all that skewed means is that most of the data is contained in that area on the right or on that area on the left. And there are, I think I read somewhere you were more likely to see skewed right, unless I'm mistaken. I'm trying to think. I think income levels is probably skewed right, because if you make billions of dollars, there's very few people on the right side that would make billions of dollars, whereas there's a lot of people who would make tens of thousands of dollars on the left. And maybe even housing market or something. There's a lot of $300,000 houses, whereas there's very few $1 million homes and things like that. So I hope this helps, guys. Make sure you're studying, make sure you're doing the homework. Thank you guys for watching.